Today we learned about Mosfet. Mosfet is a four electrode device, which means it has electrode, source, drain, gate, and body. For MMOS, there is a four electrode, and there is consisted with n plus dot source, drain, and metal gate, and p-type body. And now we can see how it works. First of all, usually source has a lot of electrons and drain has a fewer electrons because of a drain bias. So there is no bias, it will be like here picture ready. And if we give the gate bias and drain bias, it will be go lower at the drain side. So MOSFETs, we can think about a combinations of two MOSFETs. At the source side, a MOSFET has like property of here. MOSFET has if the gate bias might difference between gate bias and source then is lower than threshold voltage, it would not induce the channel because of the formerly depletion. It will be in depletion state. However, if a gate bias is bigger than threshold voltage, it will be induced a channel, which means a strong inversion state in MOSFET. However, in gate side, there is a drain bias. So formerly, it was source voltage was a 0 volt because it has grounded. However, the drain bias is not 0. So there is a problem with the gate drain bias. Here, there is a threshold. This appears because on the source side, the height is gate bias minus source voltage, which is 0 voltage for convenience. But at the drain side, gate bias is the height defined as difference between gate bias and drain bias. So at the moment, gate bias, difference between gate bias and threshold bias, threshold voltage is equals drain bias. Then the current get saturated. So to explain with the equations or something, we will use a definition of charge and current density here. So the channel charge defined as here, the electrons induced by the MOSFET, which we can see as here. Here, electron density will be defined as effective density of states on conduction band and a electron conduction band on channel surface and Fermi levels between difference. However, we can define as more easy by using these characteristics of capacitor. We can say that channel charge is equal with inversion charge, which can be defined as capacitance of with oxide and between gate bias and difference between gate bias and threshold voltage. It's okay, but it's not okay. So in here, there is a charge density formula. By using this charge, we defined with charge here, we can use that charge equation by here, and the mobility and electric field will be like defined as here, because the electron field is by the displacement over difference over displacement with difference with voltage. So to get a current flowing from drain to source, we can source to drain, drain to source. We can get a charge density over produced by a area. So we can solve these equations. We get this here, two types of equations. We call this a transistor equations. So if the gate bias difference between gate bias and threshold voltages is lower than drain source voltages, we call this a linear regions. And if gate bias difference between gate bias and threshold voltage is bigger than a drain source voltage, we can say a saturation region. The reason that we call this dividing these two regions is that, as we said, there is a threshold, and after this threshold voltage, there is a current cannot flow more than that amount of current. So now here there is a IDVD characteristics of a NMOS. So if let's say there is a gate bias and there is before this end, it will be then lower than the former ones, and there is a n plus 1. As gate bias gets bigger, then the threshold voltages gets bigger, and the saturation voltages or saturation current gets higher. However, in the PMOS, which uses a hole as channel, there is, as gate bias gets lower, then the threshold voltages gets higher, that they can drive more current by the same amount of voltage. In PMOS, the gate bias is all negative voltages, and for NMOS, they are all positive voltages. However, in saturation regions, there is not constant at saturation regions, because this pinch off or threshold because of this. So we can say as channel length modulations or short channel effect. As we said, at the gate drain side, the voltage between difference between drain and gate is not only for gate, because normally we use enhancement mode. At enhancement mode, we use this positive bias at drain. So as we keep giving a drain bias keep goes up, then there's a pinch off, which means at Mosfet there is a threshold voltage like here, which defined as strong invergence between depletion regions. If at source side there is enough difference of voltages between source and gate. However, the gate is positive bias and also drain was higher positive bias. So a difference of gate and drain are lower than gate between source. So the strong inversion state goes back to the depletion region. So that which causes a shortening channels with narrowing channels. So there is a depletion which has no channel charge. So if we using this effective length, we can derive new equations with drain current. At these equations uses with from saturation region. So by redrawing this IDVD curve here, and usually and ideally ID should be constant, but by the short channel effect or channel modulations, it cannot sustain constant because these channels get shortened. After now we thought about the IDVD because in IDVD we do not change in VG. So in here only VGN, and here only VG n minus 1, n minus plus 1, n plus 1. In IDVG, by thinking of a IDVG characteristics here, the VD and threshold voltages remain constant, remain constant. And by using this approach, we can think about that the ID is first order equation different by parameter VG. So in here, IDVD, we can use this point as, we can locate this point as here, like. So if VD's drain bias gets higher, then the slope will go up. And because here, and if drain bias gets lower, IDVG curve will get lower. So using these Mosfets, we can use as an inverter because as in here, the VG is controlled as variable voltage source, and the current flowing here to from VDD to R as drain, source to drain. So using this ID-VD curve, various type will be thought. So there is a VG and VG, lower VG and higher VG. If we define as here as high signal in a digital system, and this here off VG voltage as low, then the output will be, if we off signal comes into the gate, then will be drain voltage will be high. And also if we gate voltage is high, then the drain voltage will be off and low. So there is in MOSFET, there is a lot of there is a lot of bars, like electrons keep hard to move. He is scattering. As Matheson's law, the electrons' mobilities in total would be some summations of these here. Okay. So first of all, the impurity scatterings, which caused by a ionized charge, fixed charge from the silicon lattice, which also called as Coulomb scattering. So in here, these positively ionized acceptors and electrons. If we move the electrons, then electrons will be scattered, and also holes can scattered. At the N side, which P side, which can be negative fixed charge or ionized charge, will be banded like here. Secondly, a lattice scattering or phonon scattering. As we all know, in room temperatures, the silicon lattice will get a free charge or free holes will be moved freely, as because of thermal energies or light energies. So because of this thermal energy, the electron charge carriers can be scattered. So if we gather or some or this difficulty to move carriers, we can draw like here. Before the middle part of the chart, the impurity scattering has mainly difficult to move electrons, and after this side, right side, the phonon scattering, as temperatures go up, the phonon scattering gets dominant. The operations modes on MOSFET have two types. First of all, a depletion mode, which means that channels induced already before the gate bias get biased. So by using these equations, for NMOS, the threshold voltage would be below 0 because a gate bias will be positive, and also for PMOS, threshold voltage will be over 0 because gate bias will be negative. On the other hand, in enhanced mode, in NMOS, threshold voltage would be over 0. On the other hand, PMOS would be below 0.